All right, so page 264 today, and we are going to talk about triangle congruence by SSS and SAS. Triangle congruence by side, 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 and side, angle, side. All right, we said Monday that if all the sides of one triangle and all the angles are congruent to all the angles and all the sides of another triangle, then the two triangles are congruent. Well, there's 4 other rules that you can use to determine whether triangles are congruent or not. And we're going to talk about 2 of those today, and then after your quiz, we'll talk about the other 2. So this first rule is postulate 4.1 on page 264, and it is side, 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 or SSS congruence. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. All right, so if we have a triangle here on the left, and we label it ABC, and a triangle on the right, and we call it STR. And now, since we're looking at side, side, side congruence, we're looking at tick marks. So if AB has 1 tick mark and it's congruent to TR, and BC has 2 tick marks and RS has 2 tick marks, and if AC has 3 tick marks and ST has 3 tick marks, then we've got 3 sides of one triangle congruent to 3 sides of another triangle. So the triangles are congruent. If you were asked to write a congruent statement, again, you could label the first triangle any way you like. We could call it triangle ABC is congruent to triangle. Now, pay attention here because we went from A to B. All right, A to B. So we've got to go from T to R. All right, we got to go from T to R because look, we started at point A, and this vertex A, do you see how it's formed by 3 tick marks and 1 tick mark? Since A is formed by 3 tick marks and 1 tick mark, then the angle that would end up being congruent to that is the one in the other triangle formed by 3 tick marks and 1 tick mark. So we have to use T first. Now, since we're talking about the side with 2 tick marks, our only other option for our second vertex is the R. And since we used ABC, this side BC from B to C goes across the 2 tick marks. So we need to go across 2 tick marks on the right side. So we're going R to S. Now, you will be asked in some of your questions, the wording is determine which postulate can be used to prove the triangles are congruent. If it is not possible to prove congruence, write not possible. So in this case, if we had to write a congruence statement and explain, we would say triangle ABC is congruent to triangle TRS, and our explanation is by side, side, side. Three sides of one congruent to 3 sides of another gives us congruent triangles. All right, some things you need to see if you are asked whether the 2 triangles are congruent. If we took, let's say we took this shape here, and we turned it into 2 triangles. Now, you're going to be better off here just watching and not writing anymore for this. You see we got a triangle on the top. We got triangle ABC, and then we got triangle CDA. All right, if you were asked, are the 2 triangles congruent? If I put a tick mark here and a tick mark here, and then I put 1 here and 1 here, are they congruent by side, side, side? We've got 2 sides of the top one congruent to 2 sides of the bottom one. Now, we don't have a side with 3 tick marks, do we? But don't they both share this side CA? Everybody see that? They share this side. Since they share that side's the same in both triangles. So these 2 would be congruent by side, 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 wouldn't they? All right. Now, the only time that you can assume that is when the triangles share a side. If your picture looked like this and this, and you had 1 and 2, and you had 1 and 2, are these 2 triangles congruent by side, side, side? They're not, because in this case, you've got a side AB in the triangle on the left and a side DE on the triangle on the right, and you don't know the length of it, okay? You don't know that it's congruent in both triangles. So in this case, you cannot say that the triangles are congruent. First case, you didn't need 3 tick marks because they shared a side. In the second case, when the triangles are separated like that, you would need 3 tick marks on those 2 sides to prove that they're congruent. All right, and then take a look at the bottom of page 266 now. And this is SAS, or side angle side congruence. Side angle side congruence. And the rule states that if 2 sides and their included angle are congruent to two sides their included angle. And the triangles are congruent. And real important right here, the included angle is formed by the two congruent sides. The included angle is formed by the two congruent sides. So if you're asked, are the triangles congruent? And here's our triangle on the left, ABC. Triangle on the right, X, Y, Z. Now the rule is side, angle, side. So if I go side, included angle, and side, and then I go side, side, angle. The included angle is formed by the two congruent sides. Are these two triangles congruent? Do you see how we had the two sides that are congruent, that the angle that's touching them both is the congruent angle? And over here on the right, we have a side and a side. But this angle that's congruent to the triangle on the left, it's not between the two congruent sides, is it? So that is called a non-included angle. So to use this postulate, you need a side included angle and a side congruent to a side included angle and a side. So as this picture sits, this would be a no, wouldn't it? All right. So as this sits, are the triangles congruent? No. The angle or the congruent angle is not included. The included angle is not touching the two congruent sides. All right, so now I'm going to draw, or we're going to draw the same picture. If we go with ABC on the left again, and I go side, included angle, and side. Same picture as the previous problem. Second triangle. Draw the same triangle. Label it the same, X, Z, and Y. Now, if I label XZ with one tick mark and ZY with two tick marks, which angle has to have an arc mark in it for the triangles to be congruent? Very good. Angle Z. So now we've got side, included angle, and side congruent to side, included angle, and side. All right, so yes. Triangle ABC is congruent to triangle. If we started with A, we need to start with Z. Triangle Z, and we went from A to B. So we went across the one tick mark. So I'm going from Z across one tick mark to X. So Z, X, Y. So we're answering the question, yes, they're congruent. Here's the congruent statement. And then we can say by side, angle, side, congruence. All right, so any questions on either of those two postulates or examples? All right, then your practice problems for today. There isn't much practice related to these two rules. So part of your assignment today is going to be a review from Monday where you're going to be using a congruence statement to solve for some variables. So your practice for today is going to start on page 270. 16 through 19. 27 and 28. Number 35, that's over on page 272. And then 38 and 39. Make sure that you're checking the odds in the back of the book. Make sure you're completing your electronic assignments on a regular basis. And that you're using any downtime that you have in class yesterday, on Thursdays and Fridays, to be working in the Alex app.